Okay, so now let me talk about the collective model. That means where a model where all the nucleons are working together. Right. Now you have already you are quite late. Try to come early in the class. Okay. Now from even your graduation you have learned about this. In fact, this is one of the very first nuclear models that you have learnt of. Tell me, where did you learn about it? You remember the Bethe-Weizsäcker mass formula, right? The first thing we learn when we start our nuclear physics reading, right? Now that's basically idea of the collective feature, liquid drop, that stuff, right? So basically, in the collective model, we have liquid drop type models where extended version, fission, it can be explained, and then we can use this collective model even to try to understand not only. So, in the Bethe-Weizsäcker mass formula, basically we are concerned with the binding energy. Or overall, that means if I am talking about the entire nuclear structure, okay, this is the entire nuclear level, I am just interested in the ground state, okay, mass or binding energy. This is what I am interested over here. But again, it is not that collective model can only tell us about this. What about the fine structures? The fine structure features. So the fine structure features, it can be given by, in fact, what is known as geometric collective model. Now what is geometric collective model? As I am saying, I am talking about geometry. So you can think of it as if there is some sort of geometry involved and it is undergoing some collective motion, some vibration or even very fast rotation together, okay, or even more complex, rotation plus vibration together, okay. So you see, you can think of it, all this stuff, all this collective thing in terms of shape, vibrations. That's why it's called geometric collective model. And one of the most basic geometric collective model is rotational model, right? Then there is the vibrational model, and then it starts getting coupled. Rotational vibrational model. I will be talking very briefly about them because most of the time you have learnt about this in your master degree class, right? Now this is an advanced class, so I will be very briefly talking about it. Now you must be thinking, okay, so that's the end of the road. No. That's still not the end of the road. You see, this fine structure features, it can be explained by geometric collective model. Also, there is yet another model that you are probably unaware of till now. That is known as algebraic collective model. And there, what happens is that, you see, in the nucleus, what is the nucleus made up of? Protons, neutrons, fermions, right? Now, if you know this fact, pairing type of interaction is also there, it is very important. Now, if you pair up two pairs or pair of fermions, what do you get? Basically a single boson. And that boson consists of two fermions, like that. So, it is possible in theory that we consider the entire nucleus to be made up of bosons only, and that is the basic idea of the algebraic collective model. Basic idea, but not the complete. So, in the most basic approximation, we have interacting boson model, where the entire nucleus, now even nucleus, even, otherwise it will not be possible, right? So, even proton, even neutron. So, entire thing can be considered to be made up of bosons. What about odd even? Then we have what is known as IBFM, interacting boson fermion model. So entire nucleus made up of bosons and only one fermion. And so there is interaction between boson and fermion. Yes? So there are two fermions. So if you take two fermions, what will be the spin? Then it's a boson. Okay. So these are the two possibilities. Now, when you started learning about the geometric collective model, what did we do? We started learning about the shape, then we wrote down the radius as a function of theta and phi and all that stuff, right? Now, unfortunately, for the case of algebraic collective model, we don't proceed in that way. What we do, we start with group theoretical operators. Okay, creation operator, annihilation operator. So think of it as if there is a sort of operator which will create a boson or which will destroy a boson, something like this. So now we are going to talk about this algebraic collective model in terms of the bosonic operators. Any questions till now? So this is more or less the overall picture. Sanjay, you are late. Now previously I have just talked about the spectra, various types of spectra, possibilities, how you get the spectra and all that.